Hello, everyone, and welcome to Unit 3. This is our first unit in marking period 2, so we're all starting with a clean slate. Unit 3 is all about factoring, and factoring is basically working backwards with multiplication. So before, I gave you something to multiply, which are called factors, and you would get an answer, which is the product. Last chapter, we used expressions. So in polynomials, so when I did 2x times x plus 3, we would distribute and get our answer, which is a product. Well, this chapter is all about factoring. So I'm going to give you the product and ask you to figure out what we multiplied to begin with. That's basically what factoring is. So let's take a look at some examples. There's different ways to factor. The first type of factoring is using the GCF, and that's what we're going to focus on today. Okay. So factoring, again, is working backwards. I want you to think of it like undistributing. All right, so I want you to think of it like undistributing, so working backwards. For example, if I were to have given you 2x times 3x plus 1, you would multiply the 2x by the 3x and get 6x squared, and the 2x times 1 to get 2x. Well, now I'm going to give you this and ask you what these factors are. That's a factor, and it's your GCF. And this whole thing is a factor. All right, so basically what you're going to do is you're going to find what both terms have in common and pull it out front and then tell me what the leftovers are. Remember, GCF stands for greatest common factor. Talked about that in the last video. And that's the first thing that you're going to find. So you're going to find the GCF. And that's going to go in front of the parentheses. And then you're going to undistribute to figure out what's left. All right, and to do that, there's a couple ways to look at it. We'll divide to find the leftovers. And you might be saying, what is she even talking about? But once we get going, I think you'll be okay. It's important, too, to do a mental check at the end. Make sure if you were to distribute again that you ended up with the same thing. Okay, so the first thing we want to do is find the GCF between our terms. We have a binomial right here, two terms. So think about the biggest number that goes into 6 and 15. And you might be able to figure it out in your head. If not, remember we talked a bit about this yesterday. You can find it using your calculator. So the first step, and it's important that you write these down because you can use your notes on any of your quizzes. All right, so for the calculator, to find the GCF of just the numbers, you're going to hit math. Then we're going to arrow over to number, which is just NUM. And then we're going to go down until we see choice 9, which is GCD, greatest common divisor. Means the same thing. And you can only put in 2 numbers at a time, and they all have to be positive. So let's kind of make a little note, because when the numbers get larger and you can't do them in your head, the calculator is super helpful. So 6 and 15, you may already realize 3 is the biggest number that goes into those, but let's just try this calculator. So math, same place you go to get a fraction, but we're going to arrow over to where you see number. And you can either hit the down arrow until you get to it, or you can just hit the number 9. And then we're just going to type in 6 comma, which is right here above 7, 15. 3. All right. So that's where we'll begin. So the GCF is 3 for the number. And then look at your variables. This term has 2 x's. This one has 1. What is the most that they have in common? What do they have in common? They each have at least 1 x. So that is the GCF, 3x. And now for this part, you want to figure out what you would multiply 3x by to get back up to this. You can look at it like that. You could say, okay, what would I have to multiply 3x by to get 6x squared? Well, 3 times 3 times 2 would give us 6, and I would need an x there. 3x times 2x would be 6x squared. Another way to look at it, which I think you may like better, is just using your division. Take your GCF, and divide each term by it. All right, 6 divided by 3 is 2. And remember, when we're dividing, we subtract exponents. 2 minus 1 is just 1. You can put the 1 or leave it off. Keep your plus sign, and now let's figure out what this other term is. 15 divided by 3 is 5. And x divided by x cancels. And this whole thing is your answer. And these are the leftovers here. Now, you don't have to write GCF and leftovers each time. It's just for note's sake. But let's do some practice with it. And you're going to notice there's a whole bunch of questions. I got a little carried away. We're not going to be doing all of those. All right, so let's look at the next one. What's the GCF between 5 and 25? What's the largest number that goes into both of those? 5. All right, now for your x's, you have 4 x's here and 2 x's here. How many x's do they have in common? What is the least amount that you can take out of both? This has 2. So that's going to be our GCF. You can take both numbers are divisible by 5, and you can take 2 x's out. So again, that's your GCF. Now we need to figure out what I'd multiply this by to get my 2 terms. All right, and again, it might be helpful to just divide both terms by 5x squared. All right, so 5 divided by 5 is 1. It's gone. And when we divide, we subtract exponents, so it's 1x squared, or just x squared. 25 divided by 5 is 5, and the x squareds cancel. There's none left. All right, 6 and 10, biggest number that goes into 6 and 10 is 2. And again, if any of the numbers and you're not sure about, just use your calculator if you're not sure. All right, so we're just going to do math, go over to number, and we're going to choose choice 9. I'm just going to hit 9. 6, 10. Pretty obvious with the smaller numbers, but just to remind you. All right, so we have a 2, and then we've got 2 x's and 1 x. How many x's do they have in common? The least you can take out of both, or the most, the least that they have in common, would just be the 1x. All right, so that's your GCF, 2x. And now to figure out the leftovers, divide each part by 2x. 6 divided by 2 is 3. 2 minus 1 gives us x to the first, or just 3x. 10 divided by 2 is 5, and the x's cancel. If you have your x's written out above, the circled part's your GCF, and the non-circled part is how many x's you have left. 2 x's, no x's. 1x, no x. Just a little tidbit. All right, but that's all we're doing. We're undistributing. It's the same if there are 3 terms, if you have a trinomial. All right, so 16, 28, and 32, numbers are getting a little bit bigger, so why don't we try out our calculator? You'll see if you try to type in 3 numbers, it's not going to let you. So what you want to do, help if I pick the right thing. What you want to do is start with 2 numbers, 16, 28. So the GCF of those is 4, and then you could take that and 32. But since 4 goes into 32, that'll be your answer, 4. All right, so 4, 32. Again, you don't want to put in negatives, and you can't put more than 2 numbers in. 4. All right, so our GCF for the number part, for the coefficients, is 4. And then for your A's, again, what do they all have in common? I have 6 A's, 4 A's, and 2 A's. What do they all share? What's the least I can take out here? They all at least have 2 of them. So that 2 is your GCF. And basically, you want to go with the smallest exponent. That's the shortcut. Smallest exponent. So out of, if I have, this person has 6, this person has 4, this person has 2, the most that you can take out of all of them is just 2. All right, so that's your GCF. And now let's divide that out of each term. If you took more than 2 A's, this last term would have a negative exponent, and we can't have that. All right, 16 divided by 4 is 4. 6 minus 2 is a to the 4th. Plus 28 divided by 4 is 7, and 4 minus 2 would be a squared. Finally, 32 divided by 4 is 8, and a squared cancels out. There's your answer. You successfully undistributed or factored using GCF. All right, we're going to look at just a couple more that I think might look a little bit different. All right, with number 5, this doesn't have a coefficient, so we can't take any numbers out. So you want to just focus on your variables. So this one has 5, 2, and 7. What can I take out of each term without going over? Again, go with the smallest exponent. I can take at least 2 C's out of every one. So C squared is my GCF. All right. Now let's just divide everything by C squared. 2 divided by, you could think of it as a 1, would just be 2. 5 minus 2 is C cubed. C squared divided by C squared is just 1. Anything divided by itself is 1. So if they cancel, like over here when they canceled, you still had an 8 left. If they completely cancel, it's a 1. Anything divided by itself is 1. All right, and then 5 divided by 1 is just 5. C to the 5th, because there we're going to subtract 7 minus 2. All right, what about 6, 18, and 24? All of those are divisible by 6. All right, so I'm going to pull the 6 out. And again, if you're not sure, check in your calculator. Now, this has 2 x's. This has 1 x. This doesn't have any x's. So 6 is the only thing you can take out. Just like this one, you could only take out a variable. This one, you can only take out that coefficient. Unless every single term has it, it's not a common factor. All right, so 6x squared divided by 6, 18x divided by 6, and 24 divided by 6. So this is just going to give us 1x squared plus 3x minus 4. All right, let me just peek at a couple more here. Why don't we take a look at... let's do 8. So 100 and 150. There's a lot of things that go into both, but you want to make sure to choose the largest. So again, if you go to math over to number choice 9, if I go to, it'll bring it right back up for me. So 100 and 150, maybe you're like, oh, it's 25. Oh, it's 10. Or it's 50. All right. So we have 50, and then you have 2 x's and 1 x. You can take at least 1 x out of each. So 50x is what we're going to pull out. Divide each by 50x. 100 divided by 50 is 2, and you just be left with x. But again, you can also ask yourself, is 50x times 2x 100x squared? Yeah. All right. 150 divided by 50 is 3, and the x's cancel. All right, so this is factoring GCF. All right, I do want to look at 12 with you. Like I said, we're not doing all these examples. I went a little overboard here. None of them have coefficients, so we need to look. We have 3, 2, and 1x for our terms. I can take at least 1x out of each one, so that's my GCF. And if we're dividing by x, it means we're dropping all the exponents down by 1. So 3 minus 1 would be x squared. 2 minus 1 would just be plus x, or x to the first, minus x divided by x. Remember, if everything cancels, it's a 1. If you have 3 terms to begin with, you should have 3 terms to end with inside of there. Okay. Let's take a look. I'm not at 14. This is going to be our last example. You don't typically see them with both variables, but I figured we would give this one a try. So 9 and 27, biggest number that goes into both of those would be 9. All right, so we have 2 x's and 2 y's here. We have 1 x and 1 y. What can we take out of each term? We can take 1 x and 1 y from there. So that's all we can take from here. It's the least. You can take at least 1 x and y from everything. So 9xy is your GCF. And now let's divide by it. 9 divided by 9 is 1. 2 minus 1 for our x's would just be x. 2 minus 1 for my y's would just be y. Plus 27 divided by 9 is 3. X's cancel, y's cancel. You're done. And at any point, if you want to use your distributive property the normal way to see if you get the same thing as what you started with, it's not a bad idea. 9xy times xy would be 9x squared y squared. 9 times 9xy times 3 would be 27xy. All right, so homework's on the next page. I'm going to just assign some of these, so make sure you look carefully at the instructions on Google Classroom, and I'll tell you exactly what numbers those are. Have a great day, and stop by Math Lab if you have questions. I know this is a tricky topic, and I am more than happy to help you.